everyone. This is an intro for 2.2 part 1. So this is multiplying and dividing expressions with exponents, and there's no addition subtraction in the mix, which makes things a lot easier. So this is basically a big section on exponent rules when variables get in the mix. So I just want to remind you some of the rules. Hopefully I've got all the ones we need down. So let's see, some rules to remember. This isn't all the rules you could possibly write down, but I think it's a selection that'll get us everything we need. In general, if you raise something to the 0 power, you get 1. The only exception being x can't be 0. 0 to the 0, not acceptable. We also know that x to a negative number is 1 over x to that number. Again, x can't be 0 for that one. Fractional exponents, x to the m over n, can be written as the nth root of x to the m, or the nth root of x all raised to the m, as long as x is greater than or equal to 0. That doesn't mean this rule fails when x is less than 0. It just means that those rules are no longer all equivalent anymore, and so sometimes it might fail. So it just depends on the combination of even and odd. You'll have a worksheet that tries to walk you through that a little more. What else do we have? We have a product rule. X to the m times x to the n. If you're multiplying m x's by n x's, you get m plus n x's. And if you're dividing m x's by n x's, you get x to the m minus n x's, which, if that becomes a negative number, it's nice to write as x to the negative m minus n. So it would become positive once you put it in the bottom and switch it. What else do we need? We have a rule for raising something with a power to another power, and that rule says you multiply. Imagine writing x to the m times x to the m times x to the m until there's n of them. So you have m x's, n times n total. I'm really wishing I hadn't chosen m and n right now. The only other pair I can think of, and they really are a pair, so this is definitely a pair right here, is if you, instead of having the same base show up twice, if you have a product raised to a single power, it is legitimate to say, okay, well, if I have x times y m times, then there's going to be m x's and m y's, or similarly, and you don't really have to memorize these pairs separately. They really are the same rule, just kind of written in a little bit different way. If you have x over y, and you write that out, multiply by itself n m times, then in the top you'll have m x's, and in the bottom you'll have m y's. And let's see if there's any restrictions here. Y should, that's supposed to be a comma. Y should not equal 0. Up here, x should not equal 0. I think those are the only big ones that I can say for the general rule. Okay, so a whole bunch of rules, but again, the pairs really you don't need to memorize twice. They're kind of saying the same thing. My hope is that there's some intuitive understanding of some of these rules. So if you ever get stuck, say you're up here on x to the m times x to the n, make yourself examples. If I have 5 squared times 5 cubed, what does that really mean? It means I have 5 times 5 multiplied by 5 times 5 times 5, which means I have a grand total of 5 5s. So you can tell that you add instead of multiplying exponents in that case. So if you're mixing them up, plug in some numbers. That's always true for algebra. If you're getting mixed up, plug in some numbers and explore a little bit. The whole idea with algebra is we're recognizing patterns in numbers and we're representing them with variables. It's a huge algebra goal. Okay, so I think I'll work through at least one example and then maybe I'll chunk this off and not give you such a long video for this one. And we'll see, I might do a couple. So, In this one, we do have operations. We're multiplying two different expressions, and the expressions are in parentheses. There's no need to do any distributing. Remember, the distributive property is if you're multiplying and one of your factors has a sum or difference in it. So there's absolutely zero sum or difference here. So it really is just a matter of multiplication can happen in any order. So I'm going to see if I can't rearrange, so out in front, and you don't have to write every step here, but I'm going to group together the -2 and the 3. I'm going to mentally say, well, not just mentally, but it's fine if you mentally just think I'm going to multiply the w cubed by the w squared. I'm going to multiply the y by the y cubed. So multiplication, any order, rearrange as you please. As soon as there's addition in the mix, this is not as simple, but exponents represent repeated multiplication. So when you mix multiplication and multiplication, works out really nicely. So when I'm all done, I'm going to have a -6. If I multiply 3 w's by another 2 w's, I'm going to have a grand total of 5 w's. And if I multiply a single y by 3 more y's, I'm going to have a total of 4 y's. So that's my answer for that first one. And again, there is some memorization you have to do in an algebra class, but I'm hoping that there are big chunks that if you understand them, it doesn't feel that much like memorization. So we'll work on it. I know it'll probably take a while, especially with exponent rules. Okay, I think I'll do the other multiply, and then I'll chop this and do a separate video. So negative exponents can get really confusing, and even more so when you have negative coefficients along with negative exponents. So make sure you're mentally distinguishing those two. If you multiply something by -2, it doesn't make a fraction out of that. It just multiplies by -2. But if you raise something to the -2 or the -1 or the -1/3, that does make a fraction. So there's a really big difference there. So personally, I really like to eliminate the negative exponents before I do anything else. You don't have to do it that way. You have some pretty big freedom with your order of operations on these things. It's all kind of in the same tier. So yes, you're supposed to deal with parentheses and then exponents and then multiply, but we have rules that allow us to kind of rearrange and do that in whatever order we want. So I'm going to start with the negative first power and the -1/3 power. Really important that you realize that this negative first power right here, powers in general, they only apply to the thing they're immediately attached to. So that is -2 times m to the -1. The -2 is not raised to any power inside those parentheses. The 3 will hit it, the -1 does not. So I'm going to say, okay, first things first, m to the -1 is the same as 1 over m. And if you're feeling comfortable and you can mush some steps together, do it. I'm going to try and really split this out because tons of people don't understand their exponent rules and it causes problems. Okay, for the second set of parentheses, I have forced the -1/3 to attach to that entire chunk, 8m to the 12th. If there weren't parentheses, that wouldn't be true, but there are. Whoa, sorry. Hopefully I didn't make anyone motion sick. That was a wild one. So I'm going to go ahead and say, okay, if I raise something to the -1/3 power, that's the same as putting it in the denominator and making that a positive 1/3 power. So I would just always deal with those right away personally, otherwise it can cause some confusion. I'm going to go ahead within that first set of parentheses and rewrite that as -2 over m cubed. In the second set, I think I may as well start working on those parentheses now that I've dealt with the negative power. So if you raise a product to a power, it is fair to say you are just raising each factor to that power. I think my battery's getting low. The pen's doing weird things. Okay, so we can raise 8 to the 1/3 and we can raise m to the 12 to the 1/3. All right, so back to that first fraction. I'm going to work sideways here. If you're raising a fraction to a power, you can just raise the numerator and denominator separately. So we're going to have a -2 cubed over m cubed. And then I'm multiplying that by 1 over, and I can simplify a little here while I'm working at this. 8 to the 1/3. Remember, a 1/3 power is a cube root. The cube root of 8 is 2, and I know that because 2 cubed is 8. So this is our first time really doing some tricky inverse thinking. Division was kind of a tricky inverse thinking, but it's probably been a long time since we had to really think about it that way. M to the 12th to the 1/3. Remember that we have a rule that says if you raise something with a power to another power, you have to multiply. So we're going to get m to the 12 times 1/3, which is m to the 4. Okay, I'm getting pretty close. I'm going to go ahead and, for starters, multiply straight across. So I have -2 to the 3rd, which is -8. And I'm going to multiply that by 1. So -8 on the top. On the bottom, I have a 2. I'm just going to put that out in front. And then I can combine the m cubed and the m to the 4th. So basically on the bottom, I have m times m times m. Times 2 times m times m times m times m, 4m. So if you count that up, there's 1, 2, and there's 7 factors of m. So you represent repeated factors with a power. So that is my final answer. I don't want your answers to have negative exponents, and I don't want them to have fractions and fractions. I want you, if at all possible, oh, I lied, I'm not even quite done. I was so focused on the m. Look, we could do a little better. -4 over m to the 7. I want you to combine numbers, and I want you to combine anything with the same base. So if you can end up with a single number and a single m and a single whatever variable other than that you're working with, you are in good shape. All right, thanks for watching.